problem statement is again into the matrix world, and this problem statement is very popular, asked in many FANG interviews, and this is none other than number of islands. So let's go and quickly check number of islands. This is the problem. What does it mean? So we have a grid like this, okay, which is m cross n, m rows and columns, 2D binary grid, which represent map of 1, which is land, and 0 means water. So wherever there is 1, which there is a land, and there is a 0, it is water. Written the number of islands. So you need to written the number of island, meaning, see, 1 is land, it means this is an island, but an island is surrounded by water and is found by connecting adjacent land horizontally or vertically. So this one is, of course, a land, but but the island is surrounded by water and it's formed by connecting adjacent land. So when you connect all these lands adjacent, so then only you have to find number of islands which is possible. So for example, this adjacent land here, okay, you are moving horizontally and then you're moving vertically. So that particular thing, you may assume all four edges of the grid are all surrounded by water. So for example, this grid, it has got how many number of island? It has got one island. Why so? Because let's say if you just go this way, okay, this way, so this is one island at a time. If you just count this, um, or you can just do this way also. This is one island at a time, like this. So you can see here, this is one island. Now over here, this is one island, all right, and this is two island, and this is three island. So this one land is also an island, which is a unique alone single island. So that's why we have three islands here. So this is the problem, right? So before we go into this problem, we must need to understand, like, what should be the approach. So meanwhile you guys think of the approach, I just need to make the skeleton of the problem statement. So let me quickly, yeah, so before you guys before I start really the explaining the real brute force approach, I just quickly do one thing, copy this and go here, and I can create one class which is, let's say, number of islands. All right, and then I just write main method, and there it says input, and then we have logic, and then we have output. All right, and let's add this description to the class. Here we go. And let's copy the input from here, which is the grid. I just copy this grid like this. And this is my grid, which will be two-dimensional array. So I do this. And now I just need to, let me quickly do this way. I just need to convert to this. So I just replace all. And then I have to take this to this and replace. Okay, so yeah, so replace all, it's good. I just need to map this. Here we go. So this is all good. Space. Okay. So this is not an integer array because as per the problem, it looks like integers, and so we should not have this double quotes. So what quickly I'll do here, I'll just change this to char, and I just take this double quotes to single quotes and replace all. So now it will be char array, and I just need to format this. Let's see. There is something wrong. What's happening here? Char array, it's not happy. In particular class and not supported language level 18. Okay. I don't know what's going on here. Or will it accept this? Okay, so there is something wrong. I don't know what is wrong here. I think I need to copy this like this and okay, so I corrected this. So this is my input. Okay, so now logic. Okay, so let me copy this way. So this is my grid. And this is logic. So when it comes to logic, let me quickly create a method which is called number of island. Number of islands. And here we pass grid. And then this number of island will return answer, which is islands. And then we will print this SOUT islands. So that is pretty much all when it comes to the question. Um, now, now the solution to this, let's discuss about the solution. So the brute force approach for this particular solution is definitely we have a 2D matrix. So we need to iterate every single element into this matrix, row and column. And it has already been said that whenever you get one, you need to look for your horizontal and vertical adjacent land. So whenever you talk about adjacent, meaning either you kind of treating this as a graph. So you can either go deep into a particular path or you can just follow a breadth first approach. So DFS I would like to choose here, and I will explain you the reason why. Um, because DFS, it actually saves a lot of time. And why it saves a lot of time is again something which is very important to understand. um, See, DFS depth first search is used, and it is efficient because of the intuitive way of its nature. So recursive exploration of connected component. Whenever we have islands which are defined as group of adjacent lands which are connected horizontally or vertically, DFS starts from a cell and explores as far as possible along one branch, moving up, down, left, or right before backtracking to explore other branches. This behavior is very good for discovering all connected ones in an island before moving to the another part of the grid. Efficiency, the time complexity of DFS is O m cross n, where m is the number of rows and n is the number of columns in the grid. This is because each cell is visited exactly once. So we will be making sure that we are not visiting each cell again. So which will also um, improve the efficiency. So the program, when using DFS, it uses flat fills um, each island to mark all its cells as visited before moving to the next unvisited cell in the grid, so that it will ensure that every time we are visiting an island, we're marking it. All right. So I think that's pretty much all. Let me quickly code this DFS approach. And I think the DFS approach is the permanent solution, because we have to kind of do the marking, which is an optimization or kind of memoization technique that we will use. And we will check some mandatory conditions, right? And then that will be enough. So let me quickly code this number of islands as um, a DFS approach. So I'll go and create this method. And now over here, which is number of island, I will write my DFS logic. So int count is something which I will return. And now, as I said, I will have my first loop. I should be less than equal to grid dot length, which will be number of rows. And then again for of I, and then this will be j, and j would be number of columns. So grid 0 dot length. Pretty straightforward. I think everyone knows what I'm doing here. Now, moment I get my I, j, like moment I get my land, which is 1, the same time what I will do, the moment I get my land, I perform DFS here, DFS, and then I pass here grid I comma j. All right. And then I also do count plus plus. So what this DFS logic will do, and from here, what I can do, I can return my count, return count. So guys, always remember that this approach that I'm writing in here right now would be the standard approach for all the DFS problems. I mean, more or less the same every time whenever we solve something like that, we will always follow the same approach. So what this DFS will do, okay? So this DFS actually, um, it will starts from a cell and it will explores as far as possible along one branch. So DFS focus on one branch at a time, meaning it can either go up, down, left, but it will take one branch before backtracking to explore other branches. So one branch at a time and going as long as it can. So this behavior is ideal for discovering all connected ones in an island. So remember, whenever you are asked to find all connected ones in an island before moving to another part of the grid, it is always ideal approach to explore as far as possible. Okay. And meanwhile, when you are doing this, keep on uh, memoizing the things, so that whenever island which you have already visited, you do not visit when you come back in the same branch, you're not visiting them again. But yeah, for the other path that you're choosing in some other branch, you will always make sure that you mark them unvisited so that it can be reused. Okay, so DFS, I create this method DFS, which will be again a static method, and this will be a void method, will not return anything. I will just say this as call, and this as this will be call and this will be row. So any recursive solution should have a terminatory condition, and I think this is very common. Row less than 0 when it crosses the row, when column goes beyond the column length, uh, which is negative. So this is the negative case that we're handling. Now when row is crossing uh, grid dot length, meaning let's say whenever you are in the recursion, so we reached to a point wherein number of rows, meaning number of rows are crossing left 1 2 3 4 rows, and you are on the fifth one. So whenever you are moving your I plus 1, let's say I plus and I plus plus moves to the fifth row, so we are not checking that, we need to just stop that point. Similarly, column, it should not cross, column should not cross grid 0 dot length. And there's one more condition which is very, very important, and we have to return all starting from there is like when we know that this is a water. Okay, so row call is equals to water. So if that is the all case, we just say return, and this is the terminatory condition wherein this is the time when we have to decide, hey, this is water. You go back and check other branches. You cannot proceed further, right? And this is the common step that we always used to follow. So every time whenever we do this, we always have to follow this approach. So column equals to, and then rest all other cases is where what we will do. Let's say if the condition is all good, we are not going into that condition. We just have to first mark it because we are on the branch, and we have to mark it with, say, I can use any number, so I'm choosing 0 as my marking. So we say I mark it visited. All right. So I mark it visited, meaning this particular grid row cell has been visited. And now I just write DFS, and this is grid. And I just need to move to the directions which is allowed here. So it says you can go horizontally and vertically, meaning horizontally you can go left, right, vertically you can go up and down, right? So I would say we will go down, column will be same, and let me copy this 4 times so that we are good. Okay, so we go down here and we can go up here and the column will be same. Then we can go right, and then we can go left, and their row will be same. And that's pretty much all. So let me run this and see what is the output. So it says 1, which is all good. So let me explain you one more time what and why we are doing this. So to solve this particular problem with DFS, because DFS is an ideal approach here, we are targeting here to go as long as we can go before we do the backtracking with other branches. And that's the reason why whenever we have connected stuff, we should go for this DFS approach. So we started with his grid. We started with this number of islands past the grid here. And over here, for every single element in the grid, if there is one, we count, increase the count, and we from that particular point we try to go as long as we can using the DFS approach. And in the DFS you see here we have this very common traditional condition which makes sure that we are not going out of the boundaries, and we are not doing anything, we're not considering anything which is water. And then whenever we are processing a particular grid for a candidate which has a land, meaning 1, we just mark it as visited. So we're choosing 0 here because 0 is considered water, and we will not be considering this grid again. So I think 0 is all good here to be used. Otherwise we can use -1 or something like that, and in that case I can just add here one more condition which is -1. So grid row call, okay, is equals to -1. So this is also possible, and we can do this. There is something wrong, which is okay. So I can just, let's say, choose here 11, right? So 11, or sorry, this is 2 digits. So I just say 9 and 9. And if I run this, so you see here, this is also working. So it all depends what you are choosing. So this is only the marker because 0 was considered as water and we were skipping this. So we decided to use 0. That's pretty much all. Time complexity of this solution is pretty straightforward. O m cross n. So let me quickly write this. Time complexity O of m cross n and space is also O of m cross n, because this is where we are doing a recursive space complexity is O m cross n due to the recursive call stack. All right. Let me quickly copy this solution and try to run this. Okay, we have integer and char, so we are good here. I just thought that we will not be able to make it because of that string stuff. So this is pasted, and because I have another DFS part, so I'll just here. I'm sorry. Okay, copy. Okay. So I think that's pretty much all. Number of islands. Okay, so this is accepted. And if I submit the solution, let's see how it goes. All right, so the solution is accepted also. So you see here, we choose here 9. We can choose here also 0, and we can remove this condition from here. Anything, any marker would be okay. So even if I submit this, it will be accepted. Thank you very much for watching this video. I will be again coming with another video on metrics. Try to cover some of the interesting problem on metrics. So I hope you like it. Please subscribe. Please share my videos with people out there in your circle. I'll be happy to share as much as I can. And please do not forget to watch my system design videos, my dynamic programming videos. I'm also making videos on JavaScript, React, Redux, uh, AWS, CDK, serverless. There are so many things which I'm doing right now. So I believe you guys are liking this. Please subscribe to my channel to help me, to support me. Thank you very much.